the domain and range allow us to represent where our function exists on the Cartesian plane. That's it. So I'll give you guys a quick visual understanding of this before we actually go into how to find these things. If I draw a random function, like I just draw this, say that's my function, and say this line here, like the bottom line, is y equals -2, yeah? Can I safely say that this function, like pretend this goes a bit more straight, so we know that it just continues on straight forever. Can I safely say that this function does not exist below y equals -2? Yeah. I can't. The function there is no function from this red graph. It doesn't exist below that point. It's just not there. Is there any x value that this function doesn't exist for? Is there any x values? Like if I plug in this x value, does the function exist? What about if I plug in an x value all the way over here? Will it exist? Tarek? Yeah, it will, because you can just imagine it keeps going on forever and it'll just keep going. So what you would say here is that it exists for all x values, but it only exists for y values above y equals -2. Everyone cool with that? So let's then kind of formalize that, because it makes sense what domain and range is now, but we'll just formalize it and understand how to actually solve for it. Okay, so the domain is basically just the places in the x where the function exists. That's it. So the domain is all values for which, I'm just going to say is all x values for which the function exists. You guys can think of this as basically which values, which x inputs are we allowed to plug into our function, okay? So the question is then, how do we solve for the domain if we're given a function? Let's say I'm given a function that essentially maybe is f of x equals 2x squared plus 4, okay? Thinking about this logically, we know what this graph looks like. It's just going to look something roughly like this, okay? Something like that. Doesn't have to be exact. Can you think of any x values that you're not allowed to plug into here? When I say not allowed to plug in, I mean the math breaks. You get a math error or something weird starts to happen. Is there any value that you're not allowed to plug into your calculator as x? Not really. You can plug anything into here. Nothing's going to happen. You'll just get an answer. You will get an output no matter what input you put in. Everyone agrees? But what if I do something like f of x equals the square root of x? That kind of looks like this. What's the problem there? There is some x values you just can't plug into this. What might one of them be? Any negative numbers, right? You cannot plug negative numbers into this. It's going to break the math. If you plug it into your calculator will give you a math error, okay? So, essentially what we're solving for, to solve for the domain of a function, we have to solve for a math error. Everybody understands that? So, going on from last week, I'm going to ask you guys some questions that gets you to combine the composite functions, so this f of g of x thing. It's going to combine that plus then getting you to find the domain. Okay? So I'll put some questions on the screen and then I want you guys to give it a go, and we'll do the first one together just so you can see what I mean by solving for a math error. this question is essentially asking you first to solve a composite functions question, okay? So let's all review how to do this. For you guys that were away last week, just make sure that you pay attention to this because you're going to need it for all the other questions, okay? So, f of g of x. The first thing is, do I know what g of x is? The question gives it to me, doesn't it? Yeah? So, all I have to do is I have to do f of x minus 2. So, f of x minus 2. I can just swap g of x for what it is. That's equal to 1 over x minus 2. Does everybody understand that? Yeah? Then we're going to state its domain. Can somebody tell me what is the math error that can occur here? X minus 2 equals 0. Good. If x minus 2 equals 0, we get a math error. Everybody agree with that? Yeah? We cannot have the denominator of a fraction being 0. That causes a math error. So now we just solve this. So x minus 2 cannot equal 0. So x cannot equal 2. But it can equal everything else, can't it? Yeah? Can I get you guys just to draw this on a number line? So just draw me a number line. You have your 0 here. You have your 2 here. Can you guys please draw for me what everything except x equals 2 looks like? So you guys should have gotten something like this. You put an open circle at x equals 2 because it doesn't exist in our region. And then you basically just like color in all parts beside it. Everybody cool with this? Yeah? Now, this is the part that I want you guys to focus on. We're going to use a new notation that you guys have not seen before. And it's called interval notation. And basically what interval notation is, it's just a new way to write regions. So, for example, I can sit here and write the answer. I can write this. I can say the domain is all x except whatever, except x equals 2. I can write that, but there is a mathematical way to write that as well, which is basically whatever is represented on this number line. And I'm going to explain interval notation to you guys right now. So this is just a way for us to write regions. It's a very, very intuitive method. So I'm going to show you guys how it works, and it should make perfect sense. Looking at this number line, can someone tell me if I was to go on forever, what would be the number here? Tyrick.
Yeah.
What's the number all the way on the left of a number line? If you were to just go on forever, what do we call that number?
Negative infinity.
Cool. So here I have negative infinity. Ava, what do I have all the way on the right?
Positive.
Infinity, right? So just infinity. You don't need to like put a negative in front of it. So what I have here is I have all the way from negative infinity. So my region is all the way from negative infinity up to 2. Then it stops. It stops at 2. Then it starts again after 2. And then it goes all the way to positive infinity. So how am I going to write that? I'll just write negative infinity. Lol. Sorry. Negative infinity. 2. 2. And then 2 to positive infinity. Does everybody agree with that? So I have negative infinity to 2, and then I have 2 to positive infinity. Now, again, still not very mathematical. The final way we're going to write it is like this. It's essentially, the way we're going to do this is we're going to use brackets, and the brackets are like this. If the number is included, if inclusive, use square brackets. If not inclusive, so basically not including the number, use curly brackets. Everyone cool with this? So, negative infinity. Is it including negative infinity? I want you guys to think about this. Can we ever reach negative infinity? Can we reach negative infinity?
Yes.
Can you?
I mean, what context?
Like, if I wanted you to write down what the value of negative infinity is,
No, you can't.
like you can't reach it. It can never include negative infinity because then it'll just keep going. So you can't include a number that is like a theory more than a number, right? So we'll say it doesn't include negative infinity. Now I'll just write this as a little asterisk note. Infinity. So infinity or negative infinity is never inclusive. Everybody get that? So never ever use square brackets next to infinity because it's never inclusive. And here's all you're going to do. Circle negative infinity. Instead of 2, we just write a comma. 2. Is 2 inclusive or exclusive? Do we want 2 in the region or no? So which bracket do I use? Emma? Yeah, just a circle bracket. Then I'm going to write this, which just means union. So a union is basically just you take 2 sets and you join them together. You're basically saying the left set and the right set are all part of the bigger set. And then 2, again, 2 is not inclusive, to infinity. This is the new notation I want you guys to use when you are writing down domain or range. Whenever you're writing regions, this is the notation you're going to use, interval notation. So my answer to this question would simply just be x dot dot, or I could just write domain dot dot, domain colon, and then negative infinity to 2 to infinity. If you're ever confused about how to write the range, i.e. like which number should I put first, just think about where the number goes on a number line. You scan the number line always from left to right. Okay? So just wherever you start on the number line, you go that way and you put all the numbers in that order. Does everybody get that? Alright, so we've done that question together. Now I'm going to ask you guys some more questions. Alrighty, so give these questions a go. You will notice that the only difference between question 2 and 3 is just that I've changed this minus to a plus. So think about what that will do in terms of the question. Alrighty, so to answer the first one, we're going to first, as we did before, find f of g of x. So f of x minus 4, which is square root of x minus 4, which means that we know x minus 4 cannot equal, oh sorry, actually that's wrong, my apologies. X minus 4 must be bigger than 0. So x must be bigger than 4. If I graph what that looks like on a number line, I have 0 here, I have 4 here. Basically, is x allowed to equal 4? Yes, it is. So, because if I have 4 minus 4, I get square root of 0, which is still fine. You can square root 0, you just can't square root anything negative. So then I'm going to circle this, so color it in, and then it's just going to be everything to the right of that. To write that in interval notation, it's simply just, remember there's infinity all the way out here, so it's simply just domain is inclusive of 4 to infinity with a square bracket. Oh, sorry, a circle bracket. So did everybody get that for their first answer? Cool. So that's all you would write for that question. With the second one, we get this as well, except just the minus changes to a plus. And what do you guys notice about this? We have x plus 4 must be greater than 0, right? And again, sorry, it should be greater than or equal to 0. And again, I will just see, okay, well, what happens here? It's the exact same thing, except this time it's a negative 4. So you're just drawing this part of the region instead. So instead, your domain is just going to be negative infinity with a circle bracket to 4 with a square bracket. Cool? Everybody got that? Or no? Yes? I'm so sorry. I've done something a bit stupid. -4, it's not everything to the left of -4, it's everything to the right of -4. We're thinking bigger than -4. So what I said before about being everything to the left of 4 is wrong, because it should be everything to the right of -4. So yeah, sorry about that. So -4, and then we get everything to the right of that. My apologies. So yeah, then the domain would just be inclusive of -4 and then excluding infinity. The square circle bracket. Everyone cool with this? Yeah? And then the very last one, let g of x equal that and f of x equals that. What is g of f of x? So this time, g of square root 2 minus x equals 1 over the square root of 2 minus x. This one has a little bit of a trick to it, okay? And here's the trick. You want 2 minus x, in this case, to be bigger than 0, not bigger than and equal to. Because not only is it in a square root, but it's also on the denominator, which means whatever's inside of the square root cannot equal 0 like it did before, okay? Because if it equals 0, then you're going to cause another math error, okay? So then this time we say that 2 must be greater than x. So x is less than 2. If I graph that, that's just everything here with an open circle. So be super careful. Yeah? So everything there with an open circle. So the open circle tells us that we're going all the way from -infinity up to 2, and neither of them are square brackets. So that's my domain. Everybody cool with this? Awesome. And just like what Emma did in the last question where she realized something was wrong, you guys should just reason with your answer. So just reason with it. Think to yourself, well, okay, I'll just pick a number here like -2. If I plug -2 into this, is everything okay? Yep, 2 plus 2, 4, square root of 4 is 2, 1 over 2, that's fine. And then you can just reason with your answer that way, okay? Because, for example, what Emma said before is, I had written that it's all of this, and Emma was like, well, if you plug in -400 and then you add 4 to it, that's still going to be negative. And I was like, oh yeah, right. And that's how we pick up on our mistake, right? So it's really good to just like reason with your answers. Make sense? All right, let's get into range now. The range is the exact same thing as domain, except instead of being in the x, it's in the y. Okay, so we're just seeing where does the function exist in the y. So I am going to say that finding the range is a little bit more ugly than finding the domain. There is 2 very simple methods that you should always stick to when finding the range. The first one is, if you can graph it, you should graph it, okay? Because if you see a graph, it's very obvious to see what the range is. For example, Tyrick, can you tell me what is the range? So what's all the y values? Just tell me if there's any that I'm missing. Can I have all the y values exist for this function?
Yeah.
Yeah, because any x value will have a corresponding y value, and I can go with y forever. Like will there be a y value at positive 400, y equals 400? Probably, yeah, there will. Okay? Whereas Ava, if I ask you what is if this is a 4, is there some y values that don't exist for this function? Y values, be careful, not x values. Is there any y values that don't exist on this function? Remember, it's a parabola that always goes up. So is there any y values that we will never have on this function? No. You sure? So like, for example, y equals -2. So that's all here. Will that ever be on my function? No. What about y equals 3? Ever going to be on the function? No, so there's a lot of y values that can't be on the function. Do you agree with that? So it becomes very obvious that your region is everything up here. And for this one, it becomes very obvious that your region is just everything. Yeah? So if you can graph, the moral of the story is to graph. Okay? So method 1 would be, if you can graph, graph. So I'll give you guys an example of how to read the range off a graph. If I draw a graph like this, can someone first of all tell me the domain of this graph? Sorry? No, be careful. The graph just stops here and here. It doesn't have arrows. So what would the domain be? Anyone?
-4 and 4.
Yeah, so it would just be -4 to 4 inclusive. Yeah? Because both the 4 and the 4 are including in the graph. What about the range? So what about the y values? Emma, what do you think?
-8 and 2.
Yeah, so we go from -8 to 2. Sorry, I don't know. Sorry. -8 to 2. And sorry, it should be including. Everybody cool with that? So, domain and range is very easy to read straight off a graph, okay? You look at the graph, you see where do the y values not exist, and you just write it down, okay? Very, very easy to do. Let's look at an example of a function that would be kind of hard to do without a graph. Looking at this function, we see that, well, we actually don't know how to graph this. Does everyone agree? Would anyone know how to graph this? No.
Is that a number?
Well, ln is just like log of e. So it's like, it's a function, basically. Would anybody have any idea how to graph this? Not really, right? Just in case you're not aware, ln is a button on your calculator, so you can plug in like ln of 2 and it'll tell you what it equals, right? So you can find values of ln, but we agree that like no one would know in this class how to graph this function, yeah? So the method 2 says we're just going to do a table of values. A table of values, then graph, okay? So if it's a function you don't know how to graph, you're still going to need it to look at the graph to determine the range. So your only other option is Desmos, which you don't have in an exam, or a table of values, which you have in an exam. So it is important, though, which values you choose to plug into your table of values, okay? So let's have a look. Remember, you always plug x in. So what I'm going to do is I'm going to plug in x values, and I'm going to plug in the following. Pick one really negative number, negative number. Then pick one kind of negative number. Always pick 0. Pick a positive number. And then pick a really, really positive number. Everyone cool with that? Those are the 5 points you want to pick. So maybe you might always stick to something like -400, -2, 0, 2, and 400. Maybe those are the values you always plug in, okay? You can plug in different values as long as you pick one really negative number, one kind of negative number, 0, positive number, and then an extremely positive number. Does everybody understand that? And when I say extremely positive, don't plug in a million. Plug in something reasonable that you can then plot on your graph, okay? So, can I please get everybody to make a table of values for this? So, I'll draw out what it should look like for you, but then I want you guys to fill it in. So we're going to have, we said -400, 2, 0, 2, and 400. And then, can I get you guys to, first of all, figure out what it is? Remember, ln is a button on your calculator. I believe it is in the bottom right somewhere. Can I have a look just to double check? No, I'm stupid. It's in the top right. Click ln, and then you're going to plug in x to the 4 plus 1, depending on the x inputs. Please be careful when you do plug in the negative x inputs that you put them in brackets, okay? So if you're plugging ln of -400, please put the -400 in brackets, then raise it to the power of 4, okay? And then please draw the graph. I'll give you guys a few minutes to do that, and then we'll come back and have a look at what it should look like. And once you graph it, if you do think you know what the range is, go ahead and write the range, and also write the domain if you can. When I plug this in, do we roughly get something like 23 here?
Yeah.
And then we got like maybe a 2 here. Obviously, I'm not including decimal places. Then we got a 0 here, and then a 2 again, and then a 23 again. Yeah? No?
Oh, yeah, but like, yeah.
But like with decimals, obviously. Yeah, you should get decimals. So I just haven't written them down. So what this is going to look like. At -400, I get 23. Then I get 2. Then I get 0. Then I get this. Then I get this again. And I'm just going to kind of connect the dots with a smooth line. Cool? We agree that we were not going to know how to graph that without a table of values. But with a table of values, you can graph anything you want. You just have to do more points. Yeah? And then looking at this, can someone tell me what's the range going to be? Cool. So it's just the range, in this case, would just be 0 to infinity. And then the domain would be what? Everyone?
There is no.
What do you mean there is no domain?
There's none.
As in there's nothing you can't plug in?
Yeah.
So then that means the domain is everything. Remember, the domain is what you can plug in.
Oh, yeah.
So domain is everything. So the domain would be negative infinity all the way to infinity. That's how you write everything, by the way. All good? So method 1, if you know how to graph straight away. Method 2, if you don't know how to graph, you still need a graph, but just use a table of values. Everybody cool with that? Awesome. So now I will ask you guys some questions. So just find the domain and range of all of these. Remember, for the range, I would like to see that you guys do draw a graph. Write everything in interval notation. And if you don't know how to graph something, plug points into a table of values. And if you need to plug in like 500 points, you can plug in 500 points. It will give you the shape of the graph, but obviously just plug in as many points as you need to until you kind of know what the graph looks like. So let's go through the first one. You should be able to see there's no number you're going to plug in here and get a math error. So the domain would just be immediately just negative infinity to infinity. Everybody cool with that? Then the range, we know how to graph something like this. We can factorize it. And I get, oh no, we can't factorize it nicely, I don't think. No, we cannot. So we'll just use quadratic formula. I'm just going to find the midpoint. So because I know the midpoint will be the lowest point of the graph. So I'll just do minus b on 2a and I get minus 1. So I know that my graph is going to be somewhere here. Do I need to know what the x-intercepts are for this question? Not really. I'll just graph something like that. At least I know the lowest point. Yeah?
Well, you don't even know the y?
You do. So I'm about to plug that in.
Yeah.
So that's the x value of the lowest point, and then I'll just plug that back into the equation. So here I get 1, here I get minus 2, and here I get plus 4. 1 minus 2 is negative 1, plus 4 is... whoa, am I stupid?
It's negative 3. Sorry, 3.
No, 2... Oh, yeah. Negative... No, it's negative 1. What have I done wrong here? X squared, I get 1 squared minus 2 plus 4. Why does that give me...
1 minus 2.
Oh, yeah. Okay, that's fine. Actually, I'm not stupid. I'm just drew my graph wrong. So it's just going to be floating up here. Sorry, that should have been obvious to me, but I guess my brain's not on today. So yeah, that makes plenty of sense. So you just get negative 1 plus 4, which is 3. And that's fine. So then the range, in this case, is just going to be from 3 all the way to infinity. So, and it's inclusive of 3. So 3 to infinity.
Wait, why is
That's
it
it.
all the way up there?
That's just what the parabola looks like. If you find the discriminant, you'll notice the discriminant is less than 0, which means it won't have any x-intercepts. So it's one of those floating parabolas. Yeah? Do you remember the discriminant?
Yeah.
It was in last week's video anyway, so if you're confused.
B squared minus 4ac.
Yeah, b squared minus 4ac. Remember, if the discriminant is less than 0, then you have no x-intercepts. So in this case, this parabola just doesn't have any x-intercepts. Make sense?
Yeah.
The next one, part B. The graph just looks like this. And it's at 2. So I can see both my domain and range are both all the numbers. So domain is just negative infinity to infinity, and range is also just negative infinity to infinity. Everybody cool with that one? Yeah? Ava, you okay with it? Yeah? Okay. And then the last one. This one I should know how to solve for a math error. X minus 4 has to be greater than or equal to 0. That means x must be greater than or equal to 4. If I just quickly plot that on a number line, this is 4, and it's just got to be bigger than 4, so I can just write that as 4 to infinity. Everybody cool with this? That's my domain. And then my range, I need to graph it. Now, I'm going to show you guys the table of values method. Eventually, you guys should know how to graph this off by heart. It's just a sideways parabola, but it's just the top half of a sideways parabola, so it just kind of looks like this. But for now, if you don't know how to graph it, that's fine. We will just do a table of values. So, can I just get someone to be my calculator person with this? Can I please... Now, obviously, we know that the domain is 4. So I should only start plugging values in from 4. Don't try and plug values behind 4 because it's not going to work. Okay, so we've already worked out the domain. So Tyra, can I just get you to plug in 4 for me? And what do you get? Cool. So for x equals 4, we get 0. What about x equals, I don't know, 5, and then do x equals 10, and then do x equals 100. So for 5, you get 1.
Yeah.
Cool. The next one?
4.
2.45. So then for 10, we get 2.45. And then for 100, which would be like maybe way out here. Again, it doesn't need to be to scale. What do you get for 100?
9.8.
9.8. So not that much higher. So graph kind of looks like that, as we said. And so we can see the range is just everything from 0 all the way up. Okay? So the range, y values, is just inclusive of 0. So that's a square bracket all the way to infinity. Everybody cool with this? Yeah? So that's everything you need to know about domain and range. There's nothing else. Okay? Domain is just all the x values that can exist. And then range is just all the y values that can exist. To find the range, you will need to use a graph. To find the domain, you just solve for a math error. If there is no math error, then the domain is just everything. Okay? And please always remember to write your answers in interval notation. Okay?